Hi, I'm Kristen Grauman. I'm from the University of Texas at Austin. Going to present our work on using computer vision to understand images of clothing and fashion. And the theme today is understanding the influence or the evolution of fashion over time and across space. So first, let me just say that fashion is not just about shopping or high fashion, fashionistas. It's really about what people every day, everywhere wear. And so our clothing says so much about us, and this actually makes it very interesting from many perspectives to understand in a deeper way, and as I'll show you in this talk, in a statistical way. So the talk is about how fashion evolves and being able to detect that in photos. And I'll talk about two notions of influence and evolution. So one is, like you see here, the evolution of fashion over time in step with world events and cultural influences. And we know this happens, right? So if you look over the past decades, here looking at, say, largely American history, where there was effects from economics or world events like certain wars that affected the clothing people preferred, whether that was because it was cheaper to manufacture certain fabrics, so these certain glamorous looks became more popular, or after a war where simpler, more austere looks became more important and popular, or to events like the women's movement, where feminist looks and wearing jeans, or women in the workplace. All of these kind of events are following the decades of our history and really a function of what's happening in the world. Secondly, there's the notion of influence coming across space, and here I mean on the world stage. So we know that the styles popular in one place can influence and travel to another place over time. And we can think of this as a style migration from one city or place in the world to another. Okay, so whereas the previous slide is about fashions changing over time, this is about fashions changing with time, but also as a function of position in the world. So these are hints about what we're going to be exploring in the research today. My talk is about specifically learning fashion influence from web photos. And whenever we can, learning it in a rather unsupervised, bottom-up way. And there's two parts I'm going to tell you about from the work. One is about how do the cultural factors drive fashion trends? How can we learn this from data? And how do city styles propagate over time? So let's jump right in with that first one. So as I was just alluding to, there's events in our culture that do have an influence on the clothes people wear. From anything like the miniskirts on the left to the casual wear and bell-bottoms and so on worn by the hippies in the anti-war movement or today's social media trends. So we, of course, realize and recognize as people in the world that these connections are being made, and including in hindsight, we can recognize them. But the question is, can this be something more formal? And can we discover such links directly from data? If we could, this will allow us to have, on the one hand, a more quantitative and systematic approach to understanding when these links exist. Furthermore, it might allow us to discover things that are much more subtle than we're able to put our finger on just if we look at these by hand. So here's the goal. Can we discover which world events, which cultural factors give rise to iconic styles over time? And in the results and data I'm going to show you, this is over the span of about 100 years. So typically, if you wanted to make such kind of inferences, you could do so with the right expertise and the right data. And this would then, be done today by experts who know about clothing, who know about history, who know about how to link these two things. Of course, we're concerned that this doesn't scale, and it may miss those more subtle kind of connections. So we're looking to image data to try and answer that question. And here's a general idea that we pursue. We need to ground influence in something that we can computationally, quantitatively model. And we choose forecasting to be that thing. So imagine you know about the popularity level of a certain style of clothing over time. And in my cartoon here, we'll be taking the casual hippie style, the green curve. Suppose that's a popularity over time. Now, we could think about forecasting that's popularity in the future, and looking at this curve, we might think there's some kind of cyclic nature happening, and we might have a certain expectation forward in the future. But if we were to consider that clothing trend line against other trend lines that have to do with cultural factors, like, say, the peace movement, shown in this hypothetical blue curve, Now, if we know that these two do have some influential relationship between them, this would change what we might expect now in the future of the hippie style, right? Because the shape of the blue curve suggests what might be the shape of the green curve in this case. And notice that's very different than if I weren't paying any attention to that cultural event, in other words, the blue curve. So this is, in a snapshot, how we're going to try and leverage forecasting as a time series prediction task to ground a model of fashion influence. The particular quantity that we'll start looking at here is called Granger causality, and it basically captures what I just showed in pictures here because it says two variables are Granger, one is Granger causing the other if knowing the history of the second helps you better predict the future of the first, just like in our example here. And we can use this statistical test to identify what entities have some influential relationship and then use them to improve the forecasting. And we're actually interested in both those things, finding out what has a relationship and then down the line improving our forecast. So then let me put this together for the model that we've developed to handle this. On the one side, we have cultural factors. We decide to model this through text data. And particularly, we look to 80 million New York Times articles as a way to embody what people were talking about at any given point in time, what were the important events that were being reported. So this will be our notion of culture coming from world events covered in the news. And this, we can do some standard topic modeling, so kind of clustering for the latent topics that existed across any of these articles over time. And from that, we can obtain popularity levels, so how frequent is any given textual topic over a century of these articles. Now on the other side, we'll look at the visuals, and here we want to mine so-called visual topics from image data, and we look at vintage photos from Flickr covering, again, a century's worth of time. And so we're mining for the visual patterns that recur, and furthermore, the combinations of those visual patterns that co-occur together in a photo to establish from the bottom up what are the styles over time. So they have no names. These are just, think of clusters of visual assemblies of garments that are common enough to rise as a topic. Now for those two, we can have the popularity over time. And here's the important piece bringing these together. Now we can measure the Granger causality, which I referred to a moment ago. This is that metric that says, does knowing the past of one help predict the future better for the other versus just knowing the future of that second variable itself? Versus just knowing the history of that second variable itself. And if it's significant, and it does, then we will call them as one Granger causing the other. In this case, we want to know which events or which cultural factors Granger cause which styles. And I should note this is a more general definition than just pure correlation or shape of the curves. They may even have opposite effects. It just needs to be the case that one helps predict the other. So after computing pairwise among cultural topics and visual topics, we can come out with a list of pairs saying this event seems to influence this style. And we'll have some level of confidence for those as well. Okay, so this is cool because we're mining a century of photos, a century of news to find out what things seem to have a relationship from what's happening in the world to what people wear. Well, let me show you first a few examples, and then I'll talk about what we can do with such a model concretely. So first we can do this, which is to analyze the results. And here's an example where you're looking at, again, those two trend lines. In this case, the yellow is about the text, the blue is about the images. And what we're seeing is that this is a topic in the text shown by the word bubble on the left that has to do with things with women and women's events. And the blue is showing then on the right the excerpts of images that represent strongly for the given style that was found to have a Granger causal relationship with it. And you can see the words underneath those pictures, those are visual attributes that are also detected in the photos. So what this particular example shows is how the women text topic, Granger causes what looks like a working attire style. And in fact, they're the one, observing those events can help you predict when that kind of working style is going to be more or less popular. Here's another example in the same format. So in blue, again, is visual, and then the yellow is the textual. And here, this is a topic having to do with Africa and different world events, different events happening in Africa. And we see that this was Granger causing the style depicted over here with the attributes in the leftmost word cloud. And so again, it's showing some influence relationship between that set of events and its emergence in the news over time with this particular style. And the final example I'll show in this format, this one is a war text topic that seems to Granger influence the utilitarian attire. So these denim simple cuts. Okay, so this is neat. This is coming directly from the data without, both in terms of the topics that were found and then this influence relationship without any hand-holding by us. So this is kind of mining for what are the influential relationships. Now, two things that we've tried to leverage the model I just described to do better. One is forecasting. So this one I've already motivated, right? We say if we understand this link, we should be able to forecast better how things will look in the future. So to test this, we hold out part of the future, meaning the tail end of the data from the algorithm, and allow it to learn on the past. And then we ask it to predict how popular are these styles going to be in the future. Okay, so can it estimate what visual styles are going to be high or low at any given time forward? Here, looking at the top, 20 years forward for that vintage data I've mentioned. At the bottom, just in a shorter time frame in the nearer term for a second data set that we'll see in a moment. And so what the results show on the right basically is compared to other ways you would predict these time series, in particular ones that are simple time series models or even ones from the literature that we're trying to forecast visual styles specifically, we're getting an edge by being able to understand the link with culture. Okay, so that's really helping to do the forecasting, and in fact, it's the basis of these influence patterns. Now, the second task that we considered is timestamping, where we took this model where we know culture is linked to visual styles, and we use it to do better photo timestamping. So photo is an input, and then we're asked to produce when was this photo probably taken. So what era, what decade is the photo suggestive of? And the baseline would do this using only the visual input. Our model uses cultural input by predicting what are the textual topics that go with this photo, having learned their association before, and then using both those modalities to predict the timestamp. And that has a good impact on the accuracy, as you see on the bottom, for, again, two different data sets of styles over time. And the second one is a rather large one, some 7 million photos. Okay, so it's playing out that we can find the influence patterns that exist, and then furthermore, they're useful for some concrete tasks, forecasting and timestamping. And overall, what this work has allowed us to do is create timelines like this automatically, where the system is looking at how are the clothing patterns changing over time, how are the news events changing, and which ones are salient among the world events that, to line up against the salient style patterns. So we can create these timelines automatically. All right, so in the second part and remaining bit of this talk, I want to shift from world events and trends over time to trends across space in the world. And so here we're looking at how styles propagate between world cities. And so imagine we have, again, some fashion style like the one on the left, say it's flowered dresses. We know that in the world, for certain styles at least, there will be migration patterns where we might observe styles becoming popular in one place and then traveling to become popular next in another certain place. And these relationships are quite interesting. If we could model how styles migrate, we could ask questions like, okay, the style that was popular in Paris in this year, how long will it take before it becomes popular in Austin? Or, will styles that are trending or not trending in this particular location, will they, and with what lag, will they make it to another place? For example, so these are interesting kind of questions to analyze fashion, again, in a very broad and worldwide stage. So the question is how to do this and do it in a computational manner. So for this challenge, we're looking at a data set called GeoStyle. This has some 7 million photos, public photos from 44 worldwide cities, captured fairly densely over 3 years' time. And they're, in the wild, I think, as they get in terms of everyday photos of people and what they wear. And what's really cool about this data set is that it is just that, right? It's organic view of what people are wearing. Again, as I said at the onset of the talk, not always high fashion, just, what we wear, and it says something about, as we just saw, culture, and also now we'll see how it'll help us see how things move across the world. So again, like before, I'm going to have a model for visual styles, and then related to what I showed you, but now with the benefit of visual attributes, we're going to calculate, infer visual attributes for these photos, things like V-neck, pink top, plaid, etc., and then do some mining of the common distributions over those patterns to come up with styles that look like what you see here. Here, every 5-image row is a style, or instances of a given style. Okay, so we have those, and then now we're interested in predicting style popularity. And whereas before we were linking through influence relationships a world event or a text topic to a visual style, here we're going to relate a city to a city. So I've got 44 world cities coming from that data set, and we'll be able to say for any given style, such as the one on the bottom, is there a Granger causal relationship from city A to city B? So suppose I'm considering Seoul and Austin. Then we want to know, is it the case that knowing how popular that style was in Austin helps me predict its popularity in the future for Seoul? So apply a similar thought here, find out which cities have this relationship, and then we leverage it within a prediction model. So again, we're forecasting styles into the future, and we'll leverage the fact that we can estimate which ones have this influence in order to affect the connectivity of how we input these style trends to predict their futures. So doing this yields some good results, so some improvements on this benchmark compared to, again, some time series models that are more naive, as well as models from the literature that are producing estimates of future style popularity, as well as models that capture the fact that all these cities have different tendencies, but does not try to model the influence. And overall, what these results show is that the error is getting lower in these forecasts. So this is exciting. But we're also excited about what did the model pick up on? Like, what was it about these cities and these styles that was coming out? And what I'm showing you here are connectivity graphs showing arcs between cities when they have influence relationships. And the amount of arcs has to do with how strong the relationship was according to what we could model from the 7 million images. And after Europe on the left and Asian cities on the right, let's just zoom in on a couple particular cities where here we see Paris is an example of a multi-city influencer where there's a number of outgoing arcs from Paris to other cities showing the strength of their influence. On the right, we have Beijing, which is, according to the data, an influence receiver. So there's multiple cities coming in to influence Beijing's style. We also are interested in sorting these cities to see what's the net influence that a city has. So here, 44 cities across the horizontal axis, and the influence sorted by net influence, meaning take their exerted influence and subtract the received influence, and now you have the net influence. And what happens? So some cities are mostly influencing other cities. They have the highest net, and that's, according to this data, Seoul, Sydney, Buenos Aires, and New York, whereas others are mostly influenced by other cities like Cairo or Los Angeles. And then there's some that are really hubs, right? So they both have a lot of outgoing influence, but they're also accepting a lot of incoming influence. And this is a step towards, understanding what the numbers say and what the visual patterns say in these photos to understand big trends across cities in the world. And we can even map this out across the world globe. Here, this is a heat map color-coded by that exerted influence value. Some places here are just gray because we have no measurements. There isn't photo data there. And see my note about the usual internet photo sampling bias. But all in all, this gives us a glimpse of where influence is happening for styles across the world. Okay, so I'm going to end my talk here. I've talked about image-driven models for fashion influence, affecting how we can do forecasting, how we can start to understand in a quantitative and systematic way how world events and our interconnected world are influencing what people wear, and how we could use that to better understand it and predict it forward. This is work done with Kimberly Shao and Ziad Al-Halal. Thanks so much for your attention.